What is it? This at symbol? What is going, and all these other symbols? Look at what is this? Is the syntax can get kind of crazy if we're looking at our Rust language. There are very many situations where the syntax might become overwhelming. Many other languages have this as well, and typically the programming language is intended that the human can read it because it gets transformed into machine code, and you never really want to look at that. So what is this at symbol? This at symbol right here, what is this doing? This at sign, it's very confusing. And also there's a couple of other dots in England and that arrow. What's going on? Now we can read the code and the surrounding code, and we can sort of understand the context of what's going on. If we keep diving further, we will be able to intuit what's going on just through the context, right? We'll be able to tell what's going on with this code. This code right here is just a little interesting. So in Rust, they have something called binding, and this is binding can be, data assigned to variables, right? That's basically what binding is in Rust. Though it makes it a challenge when you're in this scenario in a match statement to be able to bind based on a range of data. And that's what's going on here. So we'll need to destruct that. This is basically what's happening. We have something called binding in Rust. It gives us indirect access to variables, it's just impossible for us to do without rebinding, but match makes it a little bit easier, or possible in this case, having the at sigil for binding values to names. And in this case, we've got in, which is the name, which is the variable name. This is kind of like saying, it's defining a variable. However, also we see here at the end, we also have another variable, we call it the in, and I don't need an at sign for that one. However, you do in a situation like this. So if we did, even though we know the value is only going to be one value, it's always going to be 0, we could say we could say in at 0. We're going to do a code walkthrough real quick of Rust binding within a match statement that uses a symbol that we're not used to. I've never used this symbol. I've never needed to use this symbol, and it is kind of confusing, especially if you look at some of the code. We're going to walk through that code right now just to see what that looks like. And we've got a function here. We're going to start off right away. Let's jump right in. A function that's age, and it returns the age, and right now it's a fixed age, right? So we've got age 15. Well, I guess it's kind of any age, right? So it could be the age of the Earth, or because U32 is a very big number. Also, it's U, which means unsigned, because you can't have a negative age, right? So U32 always returns 15. Okay. Next, we're going to jump into our main function, which is the start of the program. We're going to print out, tell me what type of person you are, which in this case will be related to the age of the person. And if we're going to be doing in person, we don't need it to be a U32. That's a little too big. Could easily be a U8. So we're going to match on the age. It's going to return. And then we have this at sigil, this very confusing at. Essentially, it's like saying define this variable, assign any data that's going to be matched on this arm for the match statement to the in variable. And then it will print, if it's 0, I haven't celebrated my first birthday yet because you are 0 years old. You can also match on a range of data, and here's where the at signal really comes in, this symbol, so we can match directly on age 1 to 12, but we don't know what the actual age is, right? We need to be able to assign that data to a variable because as in this range, we need to know what the exact value is. So you can say in at. Really, I'm trying to come up with a better, maybe how the letter A for age, maybe? That seems like maybe a little bit better. We could also probably go age, I think. Maybe will the compiler like that? Is the compiler going to be okay with this? Do you think the compiler will be okay with this? Let's make sure to get all the variables updated because we've got an age function and an age variable. Although there's a thing called shadowing. Can you shadow a function? You can. Well, then we should just use variables like this instead of just a single number. It's easier to read. We know what's going on. Now, this ... equals is granted a bunch of symbols in a row. Essentially, it's a range or a slice that you'd also use in a slice. And the equal symbol means inclusive of the last number here, which is 12. So this will be 1 through 12. If you exclude this equal symbol, it's going to be 1 through 11. Now that seems confusing. It is on purpose. Often when you're capturing the length of a list, the length of the list will be used here. So you can iterate through the entire list without having to modify by 1 in either direction of the length of the list. So it is helpful because it is the most common pattern used. So usually you would just have ... which is exclusive of the last letter. So it always... But if you need it to be inclusive, use the equal sign. And the rest makes sense. It's all straightforward. So age, assign the age to 13 to 19. So you'd be teen of age in that case. And then all the remaining numbers. I'm an old person. Anyway, I'm still not used to the syntax right here. It does look interesting. It looks weird. What's going on? The in at 42. I makes sense. We get it. We know this is called. It's called binding. We call it binding here in Rust. Essentially, the idea is it's kind of like a variable definition, a shorthand within a match statement to sort of define a variable. We can also do that here within a destructuring scenario where we've got an enumeration or a struct or an array or a tuple or any kind of, for example, wait. So we should be able to, something like this should also work, right? Actually, in this case, we want to say 42. We could do this. I'm pretty sure that'll work. Well, actually, let's go 0 to 42. So we can add another arm here in our match statement that will define, and I really like the word in this. Well, actually, we don't know what this is. This is some number. In this case, since we don't know what the number is, the letter N is fine. Let's see. Let's see if this works. I'm pretty sure that'll work. That'll do the trick. Oh no, it doesn't like it. Oh, why though? Let's figure this out. What's going on here? Exclusive range pattern syntax is experimental. Oh right. Okay. That is not. I think we have to use this equal sign, right? So then we say 41. We ran into this problem before. Is it going to work now? Magically, it works. What's going on? What is really, I mean, it's off by 1. It's just a little bit of syntax here. All right, let's line this up here so we see what's going on a little bit easier. Okay. So we've got a function up here that's going to return an option. And an option is just like a struct or an enum or a tuple. It gives you the ability to say it's going to be something. There's going to be something here of type whatever this is, or it's going to be nothing, which is great because you might have a function that returns data or it might return no data, and you have to be able to represent that somehow. Common practices you might have seen in other languages return -1, representing nothing, which is very common in C languages and JavaScript as well. When something's not found, when you say like an index search on a string, if nothing's found, it returns -1. However, that's a convention that you don't need to do if you have a language like Rust. Rust will allow you to return something that's actually meaningful because now you can include the whole range of data and then have a separate value returned actually meaning nothing. So it is a very useful pattern, and it is definitive rather than a convention. So we're looking at this match statement really quick. We run the sum number. We've got a function here, always going to return 42. So we say when it returns 42, we're going to assign that value to the variable in this case. So it's kind of the same. It's kind of like saying let n equals, or pretty much exactly that. It's pretty much exactly saying that, but just with an at symbol, which is, it is definitely more confusing. It is not obvious what's going on here. Though once you get familiar with it, you can, there's got to be a better syntax. We also check a range here, 0 to 41, and then anything. We don't, okay, we do, okay. So since it's returning an option, we do need a match on anything else, which will be the none, right? I do believe we could go like this, I think, right? It's got to be, this would be a complete match, all-inclusive. It includes the number, can be anything, but it also could be nothing, right? Because we're returning an option. Will the compiler work? Do you think it'll work? I think it'll work this time. I think that'll work. We don't need the underscore. We can just say none. It better work. Okay, it works. All right. Now, this is a little bit cleaner. I like this a little bit better. It's more obvious what's going on, except for this at sign, though we need it in this case. And we've matched all possibilities using this pattern, which is really great. I like this. So one of the nice things about Rust, it makes you be complete. You must have, well, most of the time, you can get around it, though you shouldn't try to get around it. You should just try to follow the good patterns, the good practices here.